Fossil fuels are fantastic. They're powerful, versatile, flexible. The trouble is, you can only use them once, and somebody else is always in control. I'm Stirling Paatz, and I'm going to tell you how we're going to turn that around. Renewables are all about capturing energy from the natural world. And in the natural world, everything is driven by the sun. The sun drives the wind, which is caught by turbines. The wind drives the waves, and photovoltaics can capture the sunlight. But at NGB, we're really interested in what the sun does for plants. A plant does a really good job of putting sunlight together with carbon dioxide and water and turning it into sugars and starches and other goodies. This conversion efficiency is not great, but there's a lot of plants and they're very persistent. Every living thing on the planet depends on plants. We all eat them and excrete them every day. Us more sophisticated species put a lot of effort into turning them into fancy foodstuffs, some of which involve putting them through an animal first. It's all very tasty, but these processes are quite wasteful, and at every stage there's a residue. And because there's a lot of us, there's a lot of leftovers. The interesting thing is, though, that these leftovers are full of energy and nutrients and a lot of our potable water. I believe that we're short of these things, so it's a pity to throw them away. Britain alone produces about 180 million tonnes of waste each year, which contains about 135 million tonnes of water, about 150 terawatts of primary energy, and hundreds of tonnes of nutrients. Why are we in such a hurry to throw these away and not make use of this miracle resource? The simple reason is it's not that easy to get them. A lot of it is on farms and in other resources that are scattered all over the countryside, and it's costly and energy intensive to collect them up. We're not going to try and collect them up. We're going to take the power plant to the fuel. This is our core product, Archimax. It's a modular, scalable, factory-built anaerobic digestion system designed for use where the feedstock is. Archimax takes organic wastes and turns them into biogas and digestate. Biogas is a versatile fuel. Digestate's a valuable fertilizer. There's nothing wrong with any of that. But AD is a bit tricky to get right. The biology has been around for as long as there's been biology, and the bugs are pretty tough, but they are very fussy, and they tend to nod off if things aren't quite right. So 5 years ago, we started off with a pretty deep understanding of the biology and a big list of what doesn't work in conventional AD. The result is, after a lot of research, lots of experiments, and some pretty patient investors, is the Archimax process, which systematically knocks down these hurdles. Governments are trying to, I said earlier on that fossil fuels are fantastic, but renewables are even better because they keep on coming. The problem is it's not cheap to get them, and it is harder to make money from them. Governments are trying to move things along with subsidies, but as you know, you can't rely on the subsidies being there forever. So to make a real impact and to make enough money, you need money to grow, you need to be at the top of the energy supply chain, and you need to work on a broad scale. Because we have the potential to deploy systems at a rate that are only limited by production capacity, we intend to create a big network of distributed waste-to-energy installations. These installations will provide the input energy for a 100% zero-carbon energy company. And in fact, you could argue that the elimination of greenhouse gases from farm residues could arguably make it carbon negative, but we'll debate that. We can deploy plants quickly, they're easy to run, and begin earning within a few months. By establishing an energy company and deploying our own equipment, we can guarantee the provenance of the energy and expand as fast as the market demands. We founders have put in pretty much all our own money, and the government has been fantastically supportive through DEFRA and the Technology Strategy Board, but now it's time to really get moving. Now, these are DEFRA numbers and RAP numbers. There's a very, very large target market for this deployed type of generation, and it's a perfect fit for producers and processors that have hands on the feedstock before it gets called waste. This significantly reduces the paperwork and enhances the value of the digestate as well. These production side wastes also tend to be very energy dense, which means that there's good capacity increase for every deployment. Although the plants may vary in size, they're all based on the same core modules, so it's quite easy to scale them from a small plant up to a much bigger plant. Because biogases can be compressed and stored, it's a really good complement for existing renewables. So if you have a PV installation that's filling up your grid connection during the day, you compress the biogas during the day and then spin up the generators at night, so you can maintain a good output. It's a nice balancing act. And also we found with recent work back down in Devon is that our network operators actually quite like having small generation because we're miles out in the sticks and it takes the load off of the grid. So you know, that's another good benefit. So we've already got the technology, so I'm not looking for R&D. I'm looking for help and investment to roll this out in a big way. Thank you very much.